Okay, YouTube, time for a redo. We're got our ice bath on top of our 6 pelletal coolers. We've got that big alloy heatsink on top of the small halogen hot plate. I haven't turned any of it on yet. Just the difference in ambient air temperature on that alloy heatsink versus the ice. It's giving us 1.8 volts out of all of these. I'm going to just turn this on gently. Let it soak into the aluminium, so it's on at about a quarter. It'll kick in for a bit and kick out again. We'll see the results as soon as the aluminium starts soaking it up, which is just starting to already. We'll watch the voltage jump. Now last time I did this, I only did it with a single one and only an aluminium heatsink with a bit of ice on it on the opposite side. This should give, I got over 5 volts there. This should definitely outdo that. It's creeping up. The best part about doing it this way is the heat comes up and rises to the pellet or cooler through the aluminium heatsink, and the ice obviously cold sinks. Cold air is denser. The cold will keep the pellets as cool with it on top. You see the temperature voltage rising nicely. A little bit slower than I would have hoped for. It's a bit of rubbish, just dirty stuff and fur from the heatsink just burning off there. But nothing to worry about. I did think it was the wires to begin with. We're not yielding huge numbers yet. It's still kicking in and out, gently rising. The aluminium heatsink's only a couple of degrees. Yeah, that's really not warm at all. So let's give that a minute to rev up. The ice has definitely taken the heat out of it nicely, which is good for our sake, for the reaction across the cooler to make our power. I'll give that a boost for a minute and just make sure you can actually see the frost and the steam on the bottom side of the pan. It might not be smoke, it might just be frost. Let it build up a bit of heat. The voltage is only a slow climb, but it's a steady one. Remember, this is only for the purpose of the testing. I'm not going to be using this to make 12 volts out of 240 with a great big halogen element. Obviously that's just silly, but for the purpose of testing these pelletors out, rather than having a light a fire and stick it on top of it to just test it. Still going up in voltage. It's probably about 40 degrees on the outside now, I'd say. Still rising. Never go with a more direct approach. Get rid of the steel thing. Prop you up there. I'm just going to keep them cool. My hand with a bit of ice. Straight away we're seeing much more serious numbers. Yeah, we're talking. Problem I've got now is as the ice melts, it's melting onto the aluminium heatsink, and I'm losing my temperature in the aluminium. Change to an aluminium dish on the top for better conductivity. You get this seriously quick spike in voltage with the aluminium dish. So the steel dish with the coating on it must have been insulating, which down so you can watch the voltage. I've actually got the heat off too. Shit, that's awful. The heat source is currently just being turned back on, running on low again. Got ice and water in there now. Same problem again, we're hardly touching some of the pelletors, so something like this would really need to be bolted together to provide like a really positive contact part. And when the heat or the cold gets applied to this aluminium tray, it's actually bending and buckling. But any result like this up into the above 15 volt category is awesome. I reckon these small ones will be used in a little furnace project. I reckon what I'll do is I'll set up a little burner that's got a few good decent baffles in it and a flue on it that we can burn rubbish and scrap timber in. And that should allow us to generate a reasonable voltage and then feed that back through a PWM controller or through a boost converter first, and then down to a PWM controller, and we'll pump it into some batteries and use it for something different. Converting energy essentially. I hope you found this a little bit interesting. Thanks for watching guys, and I'll catch you on the next one.